All right, good day, everyone. I do want to first go ahead and apologize. I did not realize that Mod 8 had not been ported over from the into the new way I'm doing things. So again, I apologize for that. But other than that, we're going to get started. I'm going to talk about Mod 8. So let's go ahead and get started. So if you haven't finished your ping project, I'm going to suggest you go ahead and continue to do that, work on that. Again, I'm not looking for anything spectacular. If you can go above and beyond, that's great. But if not, don't feel like you have to go ahead and spend the most time in it. Really go through the rubric and look at what I'm trying to go ahead and achieve. All I want to see is that this is actually the way it works, okay? And the rubric explains exactly how you're being graded, and that is how you should go ahead and interpret what the expectation is. Because again, this is not a programming class. This is so I can get your feet wet in this endeavor, and that way you can kind of get an idea about how this works. All right, so module 8 is going to talk about 1617 chapter 1617. In this actual section, I think there is a lab, okay? And also there's going to go ahead and be a discussion board. And it's going to talk about how you're going to do some research. You're going to see how hackers can use cron tab to exploit systems. And then there's also a little video, how hackers threaten everything from your bank account to national security. Very, very good video. I will say it gives you an idea what's going on. And then we'll go ahead, there's a quiz. I also want to go ahead and point out that in this actual module, I'm going to go ahead and talk about the final project in here. And I have the video here. I will be assigning y'all's groups this coming by the end of this week. So you'll have an idea who you're grouped together. And I'll send y'all an email saying, this is your group. Here's your server. Please go ahead and go forth and conquer. But I do go over the project itself in detail, real detail. So I'm going to go ahead and foot stomp this. If anything, you have to make sure you watch this video, okay? You have to make sure you watch that video. All right, so with that being said, let's go ahead and actually go into chapter 16 and 17. This is actually a very short section, so it's not going to take me that long to go over this stuff. So we talked about scripting and bash scripting, how we can go ahead and use the the native commands of Linux to create a simple script to go ahead and follow through with certain things. Now, what we can do with that is we can actually do what's called cronning. And it sounds like, if you're not too familiar about what cron is, think of this in a more verbal sense. Cron sounds like what? Chronos, chronological. So it sounds like something to do with time, okay? Well, cron actually deals with having things run at specific times. So these are tasks that are created or generated, and they run that task at a specific time, whether it be the hourly task. Oh, I'm so sorry about that one. Daily, weekly, or monthly. And there's one of those in each one. So we can actually, let's go into Etsy real quick. And let's go ahead and do an ls tac l, and we're going to grep for cron. So you can see right here, we have cron D, which we'll talk about, which we talked about a little bit. We'll talk a little bit more later. Cron daily, there we go. Hourly, monthly, and weekly. Now, why is that out of kilter between this one? Because this is going to be given to me in alphabetical, okay? So, but these are the different ones. These comparing programs that are executable programs. So let's go ahead and look at one of those. Let's look at cron.daily or hourly, actually. So this one is this script right here is Anacron. This is actually what gets run every hour, okay? The next one is going to be daily. So let's look at daily. Log rotate. Let's check out weekly. Nothing in there. And it's just for kicks and giggles. Is there anything in monthly? Nope. Okay, cool. So let's put the log rotate. Let's change directory to cron.daily. And let's look at log rotate, okay? So again, this line right here, remember, this indicates this is a bash script, okay? So remember the shebang bin sh, this is a bash script, okay? Now, it's line 1, line 2, line 3. This is where you execute the user bin sbin log rotate. So the word log rotate is a command, okay? And it actually can be run. Where log rotate is located is going to be in user sbin, okay? And it uses the etc log rotate.configuration file to go ahead and run that command. So then it gives you an exit value. This stores the value in a new variable called exit value. In lines 5 through 7, so that's 4. So 5, 6, 7. This is actually what determines that the exit value is not equal to 0. So if the exit value is not equal to 0, then we go ahead and do this right here, alert exited abnormally. So, and then we go ahead and exit the script with line 8. But if it is equal to 0, then this actually gets skipped and we just exit normally, okay? So you can see right here, this actually is a if statement for if the program runs, I would say if it doesn't run properly, or it did not go ahead and close out properly, it would say, hey, log rotate alert exited normally with this exit value, okay? So that way you would know as the actual admin that this is what happened, okay? All right, ManDB tac cron. Let's go look at that real quick. I'm gonna exit this. Let's go ahead and look for, and do ls. I'm going to grep for mandb.conf. So that's all I have right there. So let's go ahead and look at that. So this is the ManDB package information, which this is not the .cron. But let's go ahead and this is actually going to be the configuration file for the ManDB. So let's go ahead and just exit that. Okay. Okay. So as we see right here, we have the mandb.cron as well, the line 1, 2, and 3, use sourcing to include the code from another file. So we can see right here, we're pulling from the sysconfig. So let's actually go into sysconfig. Let's see, change to sysconfig. Yes. And we're going into man-tacdb, where it is right there. Let's go ahead and do a vim man. All right, so here we go. Set this to no disable ManDB update trigger. Services yes. etc cron daily is ManDB tac cron. Set this to no disable daily ManDB updates. Options used by ManDB, we use tacq as default. Too much noise without it. Okay. So you can see right here, this is actually calling. So if this executes, then this right here, and then we have the variable cron equals no, then exit 0. So renice and ionice, we'll talk about this a little bit more. But 4 through 12 is going to perform a set of tasks. 13 is going to go ahead and actually is the heart of the script. So we're going to do ManDB and we're going to actually do the option, which is going to be the $OPTS. And then we exit on the 14th exit script. Okay. And then we have this one right here. This is mlocate. Okay. So if you don't know what mlocate does, we can go ahead and do a mlocate tech help. Did I misspell that? Oh. Let's do ls. Get for mlocate. I don't know if I have mlocate installed. Probably don't. That's okay. That's not for this. This is actually to go ahead and get a better idea of these scripts. So again, we have the bin bash, the shebang right there at the very top. So we learned that this is actually go ahead and the calling the entire thing, proc file systems, AWK $1 equals no dev and $2 does not equal rootfs. Then we're going to print $2. Okay, so Renice. We'll talk about that a little bit more, but I just want to go ahead and kind of put a spin on that because we're using that so far. So Renice is basically a way we can go ahead and change the prioritization in regards to CPU and resource usage. And we can renice it with a higher or lower number. The more we go ahead and renice things to a lower number, the more actual preference they actually get. But the higher the number, the less preference they get. So repositories. So repository is a location where people share programs. So this is one of the most common repositories. It'd be GitHub. So you have bash shell repositories, and some of these are going to go ahead and be. I give you some examples here. Some of them don't work. You may have to go ahead and look for them in Google because the links are broken. So you may have to go ahead and find them and everything else. I'm going to try and update them a little bit later. So why is this important? Well, at the end of the day, you know the term and you heard the phrase, work smarter, not harder, right? So as an administrator, as a cybersecurity professional, wouldn't it be great to get paid your salary and then to sit there and basically read a book? You know, you're watching the Wheel of Time and you want to read the series, which I kind of don't recommend, but if you want to go ahead and be that adventurous or anything, so you would want to go ahead and any mundane habitual tasks you do either hourly, daily, weekly, monthly, bi-weekly, however you may be, you want to go ahead and actually look at automating that stuff. So are these tasks routine? What tasks take a lot of time or system resources? What kind of critical security audits can we actually go ahead and automate to the system cron tab file? Make a script that automates reminder emails before important meetings. So you can do that. Find out who's logged into the system at a certain time by making a cron job that runs the who command and mails the output to you. So that's actually a really neat thing. Make a cron job for updating software. So you can go ahead, instead of having to, why would you want to go ahead, you can make a cron job to update your system. Use script to automate your backup policies. So why would you want to sit there and overnight and back up? Make it to where the system backs it up for you automatically. Okay, so that's actually talking about common automation tasks and why bash scripting was such a huge pivotal piece into automation. So let's go ahead and talk about the next one, which is how to develop automation security policies. So we talk about, remember when we talked about in chapter 14, we talked about how we can modify the cron.allow and cron.deny to restrict access of who has it. And this actually also applies to the AT as well, the ACT command. And so what you need to do is you also need to make sure your security policy reflects this. Who can use these files, and the file content should be modified to reflect the policy. So that's going to be really important. Like, is it going to go ahead and be, are you going to go ahead and give, Timmy in accounting, are you going to give him authorization to go ahead and have access to the cron tab? Maybe you don't. Maybe if you want, you have it till Timmy says, hey, I want to go ahead and automate this system. Can you go ahead and help me with that? And you basically go ahead and design it for him, but you still control it, okay? So it's up to you, but you have to go ahead and actually kind consider these best practices. So in critical systems, remove access to cron tab for all users, okay? There should be nobody that has access to cron tab on critical systems. Workstations provide access to all your users who routinely use the workstation and deny all others. So if Karen logs into 10 to workstation to, let's say this is workstation 72, and that's her workstation. She always works there from that computer. Then she should be the one that has access to it, and anybody else that logs in can't access it. You need to make sure you're monitoring the cron tabs and app jobs on a regular basis for suspicious jobs. So you should have a baseline about what's running. And we talked about baselines throughout this course. How to establish the baseline. So you want to create written rules for the use of cron tab and app 2. And this is where the policy comes in. So make sure specific files and directories related to cron tab and app jobs are properly secured. So again, you want to make sure that whoever can actually edit those files has admin rights, and that's only it, or how you want to do it. They do recommend you looking at pages 283 to 284. This will give you some ideas on various folders. Remember, each system has its own cron tab and app system. So if you have multiple systems, you have to make sure it's reflected across the entire gambit of systems. Any existing cron tab and app jobs will still execute even after you remove a user's ability to create new jobs. So that's a really important key factor there. Knowing that you actually, even if you go ahead and remove their ability, if they went ahead and you gave it to them accidentally, and they went ahead and created their cron jobs or their app jobs, they will still run even after removing them because they're still in the system. So you have to make sure you not only do you remove that person, but you also go ahead and check and make sure that you remove or disable the jobs that they created, okay? Consider really where do you place your scripts? Make sure only authorized users have access to them and the ability to execute them. So again, where are you gonna put these people? Should everyone have access to them? If you have a script that go ahead and does a backup of mail, okay? It does a mail backup. Do you want someone that doesn't handle the mail server messing with that mail backup? Or maybe you don't have the mail person. Maybe you have a backup technician. And that's their job, is to go ahead and maintain all the backups for all the critical systems. So do you want someone else that's not a backup engineer helping you out with that? That's gonna be a question of whether you want to answer that. Which systems do you place scripts on? Again, bash scripts are publicly accessible. So, and these pose greater threats than on an internal server. So if you have a web server, do you want a bash script on your web server if you're hosting on Apache or Tomcat or Nginx? Nobody should be able to modify these scripts except its owner. And that's a really important part. And we talked about that a little bit in the group permissions, in the permissions section. We talked about those ideas like the sticky bit and restricting it from, this is the only person that can edit this, because if that is restricted to that one person who can edit it, that means that nobody else can touch it. Nobody else can do anything of the sort. So you want to make sure you're using the suid and this sgid. So that's gonna be the sticky bits. Never play suid on a bash script. Why? Because you need them to be able to go ahead and this is kind of counterintuitive, because you're like, well, I want to go ahead and restrict who can modify it. But why wouldn't I put the suid in sgid? Well, here's the reason why. Sometimes when you run those scripts, it needs specific to run at a specific level, okay? Well, what if the person isn't that specific level? That can be a problem. Okay, users must have read permissions in order to execute a script. Again, we talked about this. You have to have execute to be able to execute it. You can't execute it if you can't read the script, okay? So users can see it. So if you take the user's ability to read the script, they can't execute it. Your script policy require all scripts be free of sensitive data. There should be nothing in there that should be PII or actually anything related to any of the systems. It is safer to use the absolute path when executing commands in a script. Otherwise, the user's path variable determines the location of the command. This is really important. We talked about this actually earlier on in the very beginning of the semester. But there is a variable called path. And let me go ahead and just, here we go. So here's my environment, okay? I use that by typing the env command, environment. So let's go ahead, I wanna go ahead and look at this a little, let me clear this up real quick and do environment. Okay, here we go. Okay, so here's my environment. That is all this right now is mumbo jumbo. And some of the stuff you're like, oh, okay, there's the SSH ask pass. Okay, cool. Here's more of my mails being stored for the specific user. Here's my shell that I actually get started every time this user logs in. But the one thing I want to go ahead and look at is this right here, okay? Path. The path environment variable, okay? Notice it's a listing of different directories. So everything's separated in this one by a colon. So each one of these are their own separate directories. So you have this one, and then you have this one, and then you have this one, okay? And so on and so forth. So what this means is this path basically says that when I run a script, okay, if I don't give it the absolute path, let's say I give relative path, okay, this right here is what the operating system checks first and to find the actual script, okay? This right here, it'll check every one of these. Now, these can be edited, okay? You can edit them, but this is how it knows how to do that. And then when it can't find it in any of these locations, it then tells you, hey, I don't know, that file directory doesn't exist, okay? So let's go ahead and let's do this, /ping. So what it did is it went through every one of these locations looking for the program called ping. Let's do this. And it says, hey, there is no program called ping in there, .sh. So it doesn't exist. So this is very important. So you want to make sure that you're using absolute paths, because that way, if you have your system configured differently, or you have it customized a little bit differently or uniquely, then you basically prevent a user from relying on this variable. So what you're doing to yourself to go ahead and help you out in the end actually is also helping out someone that does gain access into your system. Okay. So you want to avoid running critical commands that are based on user data. Do not accept the value from the user and then try to execute the password command using that value. Yes. Do not try to go ahead and take any type of critical commands and everything except data based off of that. Do not trust that environment variables are correctly set. So this is another thing. You want to make sure that you are using what you know, not what you believe to know. So you want to make sure you're also performing validity checks on all user-related data. So you want to make sure that is it valid. So if you're asking someone for a username or an email address, you want to make sure that it's an email address. Okay. So setTACU causes your shell script to exit prematurely, but unset variable is used. So if we're trying to go ahead and actually use a variable that's not set in the environment, then we can go ahead and then from there, it's like, hey, no. setTACF causes the expansion of wildcards to be avoided. Wildcarding sometimes is a bad thing. It's a good thing for us, right? But it's a bad thing too, because when you go ahead and wildcard something, that means you can get access to everything. Okay, we talked about wildcards in glomping. setTAC-E causes the script to exit automatically if any command in the script fails. So these are really some shell settings you can actually also set up in your terminal to help go ahead and alleviate some of the situation we're talking about. So there's just shell style guide. Just like there's a writing style guide, there's a shell style guide. And it includes many best practices that can result in better shell scripting, okay? It's not a requirement to read through this, but if you execute another user script, read the script first, make sure it executes the correct commands. So you want to make sure you're doing that. And that shell script style guide can actually help you go ahead and understand what's happening a little bit better too. And notice, I'm probably going to bold this, especially if you're running something off the internet. If you grab the script from GitHub, one, plagiarism is still a thing. It's not your code, you didn't write it. Two, you better know exactly what that code is doing, because people put stuff out there for people to download and say, hey, this is what it's going to do. And it does something totally different. And it's something you don't want it to do sometimes. Three, if you're going to use someone else's code, you should definitely know what they're doing. What is it that they're doing? Does it even address what you're trying to do? Okay. Sorry. 17. Oh, okay. I did a double. Save that. So yeah, so that's the end of this chapter, or this module. For the word of the week, I'm going to go ahead and tell you the word you should be looking for is automation. Okay, automation. That is going to be the way of the future. That's going to be what you need to be able to help yourself with. So for attendance purposes, you're going to go ahead and want to go ahead and put in automation. If there's nothing else, please email me. If you have any questions, I'll be putting out more information the rest of this week in regards to your final project. Other than that, I will go ahead and say, again, I want to stress this, it is a group project, and everyone that doesn't participate, their grade will reflect it. I have a very unique way of taking care of that, and you all will go ahead and talk about that or get exposure to that when you go through the actual video. And I will go ahead and talk more about that a little bit later. If there's no other questions, if you have any other questions, please email me. Or any problems with the quizzes, please let me know. I'll be happy to go ahead and get those things done. Other than that, y'all have a great rest of your day, and enjoy the rest of your week. And then next week I'll start mod 9, which means that we are going to be definitely, after this mod, we're 3 modules away from the end of the semester. After next week, so we got 10, 11, 12, and then we have the last week of class, which on that I will actually go ahead and try to schedule a ending class so we can go ahead and collaborate and everything about that. But other than that, y'all have a great rest of your time, and yeah,